Hello everyone, how you doing? Welcome to this coding explanation of how to code our Sumobot. So we're going to be taking a look here at how to create the code that you've seen in the book that will allow your Sumobot to react with 4 decisions. Please keep in mind this is an example code, so the possibilities are truly endless in terms of how you want to remix this, edit, enhance, modify this code to make it work for your needs. And as always, we would always love to see the work. So let's go ahead and dive into the coding for the Sumobot that you've just built. Now, we talked about earlier how we wanted to focus on certain strategies: low to the ground, preventing our robot from being flipped over, and to have torque. We geared down our motors to our wheels in order to have more power to push. So, with that in mind, our code is based on those principles. So we're going to start here with the standard when program starts. You can always find these in the yellow events block here. And what we're going to do first is we need a countdown timer. So in our Sumobot arena, most Sumobots have a countdown timer. This allows the person to start their code and then to back away from the arena. We know now with this Robot Inventor kit that we could actually just activate it from Bluetooth, not have to worry about it, but not everybody might have the Robot Inventor. So we're going to go ahead and just plan for that same thing. Usually there's a 3-second countdown. So we'll go ahead and just get that added here. So I'm just going to add a 1 here. Actually, I went a little bit ahead of myself here. Let's go ahead and add another one in here, and let's make this a 2. And what we're doing here is just creating this countdown timer so we can see on our brick the countdown itself. This will make sure that the robots start relatively at the same time while we go here. And so we're just changing the light pattern on our robots here. And we'll go ahead and finish this up. And there's our 3, 2, 1. Now, once we have that, we want to go ahead and get started. And so what we're going to need to do is we're going to need to create one variable. And this variable that we're going to create, I'm going to call it action. You can call it whatever, but this is the decision that we're going to use. And we're going to put this variable in different states depending on the decisions of our sensors. So when we create that variable, you can see up top now we've got 2 blocks here that we can use. Now what we're going to do is we're going to start off with our robot in the default of position 1, and we'll explain that here in just a minute. After we've got that, we want to drop over here to our control, and we're going to put in a forever loop block here as well. This is going to allow this program to run until we decide to turn it off when the match is over, whether we've won, lost, or a draw. And in here, we're going to have our robot make several decisions. So we're going to go in here and we're going to put this if block, and it's going to nest inside this forever loop. But for now, I'll pull it out over here just so it's a little bit easier to see here on the screen. And we're going to drop over to this operator block, and we want to put a condition in there of when our variable equals a certain number, a numerator. So we're going to put this equal sign in here. And we can go to our variable now, and we can drop our action variable in here, and we can say if action equals 1. And you know that that's what we have up here to start our code, set action to 1 right here. So this is going to be the code that's going to activate our robot to start moving. And when we get going, we want to just move straight. And you can see we've got some movement blocks here, but the one I really like is down here, this more movement. So if you haven't used these before, you have these extension blocks clear down here in the bottom left corner. And when you click those, you can add these extra blocks if you would like. I've already activated more motors and more movement. So I'm going to go here to more movement. And I'm just going to add over here the set movement motors. All right, excuse me, to start moving. We're going to start moving straight. And I'm going to keep my speed, because of the gears, I have to go to negative power and move forward at negative 25%. And you can tweak this however you would like. So remember with our gears, we have one set of gears coming together. So the gears make the wheels go the opposite direction of what they normally would. So we have that just like so in this block. And actually what I'm going to do, I'm just going to duplicate this a few more times so I don't have to do that if statement over and over. I'm just going to put those there off to the side here. And there we go. So our first movement block, anytime our action variable is at 1, we're just going to be moving straight at a nice, idle, slow type pace. Nothing too extravagant. Now, let's go ahead and drag this other if block. So if action isn't equal to 1, then we're going to skip down here. This is when action is going to be equal to 2. And what this one is going to eventually be doing when we activate our color and distance sensors is this is what's going to happen when our motors, or excuse me, our color sensor sees a certain threshold of reflection light. And when that happens, we want it to back up. So on our Sumo arena, we have the black arena with the white perimeter. So in this case, anytime it sees white, we want our robot to back up. So what we're going to do in this set of code is we're going to go ahead and just go up to regular movement on this one. And we're going to go ahead and set the movement speed here. And we're going to go ahead, we want to turn around pretty fast. So I'm going to make that 75% of our speed. And then we're going to move. Okay, even though this is going forward, remember because of the gears, everything's backwards. So this will actually be going backwards. And we're going to go backwards for 2 rotations of our wheels. You can adjust this if you want more or less. I like 2. It seems to be the perfect kind of number for me for where I want to go. And then we want our robot to then move. And we want it to move in a different direction. I don't want it to be stagnant and move the same direction every single time. So one of the things that I like to do is to add this operator. There is a really cool block in here called pick random. And what I can do here then is set this from any numbers I want for the most part. Well, not any, but a certain threshold, -100 to 100. And we're going to go ahead and let's go ahead and do that. Let's have it move in whatever direction that is for 2 seconds. And once it does that, we want to go back and set the action to 1. And it's going to start having our robot go straight again. So in this loop, it sees white. It's going to go back up fast for 2 rotations. It's going to pick a random number, angle to go, and it's going to go that direction for 2 seconds. And it's going to go back up, set action to 1. And it's going to kick out of that. It's going to go back up to this forever loop. And now action is now 1, so it's going to come here to this if block and start going straight. It's going to keep cycling through this forever loop. It goes through so fast that you're not even going to notice that it's making all those readings while it's moving. So now we want to put in our third decision. Actually, let me go ahead and move this down here so you can see this here a little bit. This might make it a little bit easier. There we go. And when action equals 3. Now this one is when our distance sensor is triggered. It senses a robot nearby, and that's when we want our robot to strike. So what we're going to do here is we're going to move straight, and we want to go a little bit faster. I'm going to put -50%. You might want to test this, maybe go a little bit faster and see what works best for you. Just for the sake of this, we're going to keep it here at this relative speed. The other thing I like to do is add a sound. So I like to do this when I beta test. I like to do this when I'm running my robot, because I want to make sure that when this is happening, that I can not just visually see it, but also audio-wise hear it as well. I'll just do the cat meow for this one. What this is going to do, it's going to meow every time our robot detects a robot nearby. And we might want a more menacing sound, but we'll keep it at cat meow for now. And what we have here is we're going to put in a wait block right underneath this. So this one's a little bit different from the first 2 actions. And what we're going to wait for, we're going to go here to our sensor, and we're going to wait until our distance sensor detects farther away than, I'm going to put 8 inches. Again, you might want to tweak this a little bit for this, but at least now you have it. And when we do that, we're going to set our action back to 1. So what this is saying here is when we get this activated, when our robot detects an object within, in this case, we'll see here minute 6 inches, it's going to start moving straight at this 50% power. And it's going to make a meow, and it's going to keep doing that. It's going to keep pushing this robot forward. We want to push it off the arena. It's going to keep doing that until the ultrasonic sensor no longer detects an object within 8 inches. And when that happens, It's going to kick action back to 1. It's going to pop back up here. We'll still be moving. It'll just be a slower speed until our next sensor is triggered and we make a decision. Our last action step that we're going to put in here for this demo code is if action equals 4. This is going to be the condition here of what happens when our ultrasonic sensor, when our distance sensor is triggered, and when our color sensor detects white. We got to have a condition for that so we don't push our own cells off of the arena. So what we're going to do here is we're going to go up to movement, and we need to just stop the motors right away. So we get that close to the edge, we want to stop. And we're going to set our movement speed here to 75%. That's going to be going backwards. And we're going to go ahead and move just 1 rotation, just enough to get away. We don't want to get too far away because we want to be able to still push this robot off, but it's just enough to make sure we're getting away from the edge. And then what we're going to do is we're going to set our action to 1. So it's just going to do a quick little backup, and then it's going to kick back to make that next decision for us to start moving straight and then to find out what in the world we're going to be doing next. So this is the main code that we have, but what we're missing now is how do we actually get our robot to change these to these different action stages, these different decision-making blocks of 1, 2, 3, or 4. So we're going to go to events, and we're going to go here, we're going to drop in when a program starts block again, and we are going to add a forever block again, and in here is another if statement. And here's where we start to put in our sensor data. We've got lots of different options here. One of the things I originally started with black and white of just pure color, but these color sensors are so incredibly powerful and accurate that a small white speck on my arena was activating this code. So I'm going to move it to reflection, and I've already done some testing. I put my robot color sensor on the black, on the white, and try to find that threshold of where I want it to be. And so what I want to have is when it's greater than 90%, it's a pretty stark difference there. I really want to make sure that it's detecting that white and nothing else close to black. So when it detects a reflection greater than 90%, we just want to activate action to 2. So this is saying, and this will be forever running just like this code, all right, just like this forever block right down here. Every time it's going to be reading, if the color sensor detects white, it's going to kick it over to number 2, and that's where we do this work over here where we back up, move it randomly in a different direction, and go. All right, now I can just duplicate this, and we're going to do the same similar kind of structure, but we're going to be doing it for our distance sensor. So now we're going to go to our sensors, and we're going to pick our distance sensor. And what I want to do here then is, let me change this. This needs to actually be port C for our code. There we go. And this is port A. That's good. So now when a object is closer, I like to use inches. You can pick centimeters if you want, or percentage. If a robot is closer than 6 inches, we want to move this to action 3, and that's where it's going to meow, it's going to pick up the power, and it's going to start just pushing. It's going to keep doing that until the object's at least 8 inches away, and then it's going to kick out and go back to stage 1. We also want to put in here one more block that we can do as well. And we could just add it in any of these. I've made these separate, but we don't necessarily have to do this. I'm doing it more just for display purposes. All right, so we could do another when program starts. Actually, let's just go just like this. Let's duplicate this whole thing. And now we want to pull this out. We want to have that activation of when we detect our opponent and we detect the white barrier. So what we want to put in here is one of these operators, the AND operator. So now we want to go to our sensors. If our distance sensor is closer than 6 inches. Oh, we lost our AND here. Let's try this again. There we go. And if our color sensor, that's going to be a little hard to see here. I'll slide this over, which is in port C, detects greater than 90%. So what happens if both of these are activated? We want to set that to 4. And that's what this code is down here. It's just going to stop. It's going to back up for one rotation, and then it's going to kick back. You can see I've done these over here separate. I could also just put all of these just like so. And I could just drop this if just like this as well. So we've got lots of different options in terms of how you like your coding preference. Either way, even I think in the book I had it a little bit separate. I had it looking like this because they were using the distance sensor in here as well. I think it looked like this. And we need a forever block in here. So this is how it looks. This is how it looks in the book. One's not better than the other. It's just to show you some different options. So this is the code, and obviously you can tweak it to make it your own and fine tune it, but this will get you some initial success in the Sumobot arena. All right, my friends, I hope you found this helpful, and best of luck with all your Sumobot competitions.
Yeah, I got a naturally mixed